Hello, I'm Benjamin Lungwitz. I want to talk today about cell dependencies and execution barriers. This is now a talk about technical things of Pluto itself. And just if you want to reproduce this notebook, please be aware that it's currently not working with the standard Pluto version, but you need to take the Pluto code from this pull request, which is linked here, because it's using some experimental features which are not inside Pluto, inside the main branch of Pluto or the release branch yet. The motivation is for these features is reactivity is great. There's no hidden state in your notebook which could introduce some bugs or non-reproducible behavior. For that, I could really recommend the slides or the talk of Joel Cruz. I don't like notebooks. And when you know Pluto and you compare the griefs he has with notebooks, especially this talk is based about Jupyter notebooks, then you will see that most of the griefs he has are not present in Pluto, because Pluto has reactivity, has no hidden state, and is working perfectly with version control systems, because the notebooks are just Julia files. And also what we've seen, what is practically used in every talk now, when you change a variable slider, whatever, then all cells are automatically updated, which is really, really good, because it's probably the easiest way I know to build a GUI for some visualization. And there are lots of more reasons you probably know because you're here. But there's one thing: why is my 10-minute long calculation cell executed all over again? I have one cell which does, or a few cells which do really hard computational work, and which should only be updated in, very rarely in certain circumstances, but due to whatever reasons, it's all updated and my nice reactivity is gone. That happened to me quite sometimes, and maybe also to you, or quite probably also to you when you're using Pluto a lot. That has, I would say, in my opinion, that comes down to two things. The first is that dependencies are not always obvious. That means it's very often it's clear which cell depends on which, but not always. And sometimes dependencies could even be accidental, like when you have a typo in a function and you're referring to a global variable instead of a function parameter or something like that. And then it's valid Julia code, but reactivity could be different than you expect. And the second thing, maybe you don't want reactivity for that specific cell, which takes so long. Maybe you want to first do to update three input sliders, and only if you're finished updating these three input sliders, then you want this long-running cell to execute. This in principle would be possible in the moment to protect it with the long-running cell with a checkbox or something like that, but this is quite tedious. The question is, how could we improve these things? For the first point, we should make it visible which cell depends on what. This is called here cell dependencies, and addressed in this now merged and also released in Pluto 0.14.1 pull request 891. And the second is we could mark specific cells not to be updated automatically. This is this execution barrier, this still experimental work in progress, pull request 985. Okay, cell dependencies, what does it mean? That it's in principle available. That means that we now have all the information available in the front end. That means we could show cell dependencies in the both in the Pluto JavaScript front end and in JavaScript code in Pluto cells itself. What we unfortunately don't have yet is an implemented GUI for that. That means, we are still thinking about how to show it in a GUI, and also someone needs to implement that. And maybe this is something where you can help. Their help would be definitely much appreciated. Okay, how do we get the dependencies in the front end? You probably know the debugging console of a browser. In Chrome, you get it with F12. Like, one thing we want to know is the execution order. That means your cells are, of course, not shown in the order they are executed. When I just execute that simple JavaScript, then you get here, okay, it's a very, very long list, but this is in the end the order these cells are executed, and each cell has a hash, not a UUID, and this is the order of the cells which they're executed. This is one information we now can get in the front end. And the second, maybe more interesting, are the cell dependencies. For cell dependencies, we are saying we have upstream and downstream dependencies. Upstream dependencies are all cells where the current cell depends on. And downstream dependencies are all cells which depend on the current cell. That means the current cell is re-evaluated when an upstream dependency changes. And if the current cell changes, then all downstream dependencies are re-evaluated. Okay, there are in the cell dependencies structure, which we can show here. And yeah, this looks like this. That means we have here a list of cells. We can just put one cell. Okay, it's a little bit, a little bit boring. Maybe, this one, for example, depends on the function, multiplication function, and on the sleep function, which are Pluto standard library, and it depends on the variable.
Could you zoom in on the right? So click on the developer console and then Control+ to zoom in.
Okay. Cool. Okay, let's this one. Yeah. Okay. Oh, yes. Now it's getting. Oh, sorry. I have to rip. Give me 1 second. Is it better now?
This is perfect. Thank you.
Okay. You're welcome. Where was I? Here. Okay. We have the variable y, which is defined in that cell. Downstream, we see that the variable u depends on that that cell. Okay, this is something we could get programmatically. Like, we could write a small JavaScript, which is, I will just hide the development console. Then we could have a small JavaScript which looks like that, which fetches all the data and then creates code which we couldn't put into a UML diagram, which we could use to illustrate these cell dependencies. These are the shorted cell hashes. These are the variables, and these are dependencies. Like, this one defines x. X is taken by these two cells. This cell defines y, which is taken by these 3 cells, and this one defines then z, which is taken by this cell. This would be one possibility how to illustrate cell dependencies in a Pluto cell. Okay, we can fetch it in the front end in the development console and in Pluto cells, but yeah, it's some kind of, we rather wanted to have it some kind of integrated into Pluto itself. Is that possible? What I will just show you is how we can get that. This would be a very, very ugly mock UI.
So could you also zoom in Visual Studio Code? It's also Control+, I think.
So, yeah, 1 second. I'll just hide that here, and we can see a little bit better. I hope you can see it. What
zoom in? I think the text is too small.
Still more? Okay.
So Control+ should zoom in.
Right, why is it not? Okay, Control+. Okay, now it's better. Sorry. Okay. Then I can hide that one, and now it's hopefully okay. Okay, what we can do is we can comment out or put that part. This essentially, oops, sorry. When we put that code in, just save it, just modify here the Pluto and just reload the page here. And then we can see something happen. These ugly lists are appearing over each cell. These show you the upstream dependencies of each cell. Of course, these are only markdown macros. When we scroll down a bit to this demo, where there's actually some kind of logic where there are some cells which depend on each other, then you, for example, can see that this cell depends on multiplication and on X. And now click on X, jumping to the cell which defines X. This would be just a very, very simple and very, very ugly method to display the cell dependencies directly in Pluto. Another way would be to which is at least as ugly, is just showing more or less the raw data of the dependencies. Again, I just modify the JavaScript code of Pluto itself in Visual Studio Code, and then I just reload. I don't need to restart anything. I just reload the page in the browser, and now I see for every cell information like we've seen in the debug console. We see the cell ID, we see the upstream dependencies and the downstream dependencies, and a number called cell precedence. The cell precedence is used so that things like using statements are executed first. We can also see it. There is somewhere a using. Where is it? Somewhere is using, and this should be executed first. Okay, I don't see my using. Okay, anyhow, here, Pluto UI, using Pluto UI has a cell precedence of 6. That means this one is executed before the other cells. And again, we see like this cell here, for example, this has the upstream dependency on the built-in function sleep and multiplication, and on the variable x, which is defined on that cell. And it has downstream dependencies. That means what depends on that cell is are these cells, which are all dependent on the variable y, which is defined in that cell. That means you could, of course, define multiple variables in a single cell, and they all depend on them. Okay, so let's switch that off again and come to the second part, namely the execution barrier. This is, I would say, a little bit nicer. Use what I just said. Use cases to somehow protect computationally intensive cells, or to have some step-by-step computations. And you can activate the execution barrier in the moment by right-click on that run button here. And like, for example, this cell takes quite long. This takes, as a sleep, takes 2 seconds. When I now right-click on the run, this cell is grayed out. That means if I now change X, then this cell is not re-evaluated again. And all cells which are dependent on this cell, either directly or indirectly, are now grayed out because they're not updated. And I can right-click on that run button again, and then this cell is re-evaluated and all its dependencies, and everything is correct. And the notebook state is always guaranteed to be consistent. I can also deactivate, of course, other cells or multiple cells. When I now activate that one, then this one's executed, and I can also activate them back again. And the execution barriers are also stored in the notebook file. That means somewhere here is now, here. Here you see this is an execution barrier. When this is active, then it is saved in the notebook file. That means if you open the notebook again, then the execution barrier is persistent. When I remove it again, it's also removed in the notebook.jl file. And it's backward compatible because when you open that in an older Pluto, in a Pluto version without execution barrier, it's just a comment in the first line of a cell. Okay. Then any questions?
This is awesome. So Benjamin has been working on this very recently, and we talked a lot about this feature before, but it's only like in the past weeks that it's coming to life. I know that Panayotis love seeing this. It's really cool.
And also supported me very Also thank you to you two for supporting me with that.
Yeah, of course. Yeah, so I think maybe one thing of the PlutoCon is that we want to inspire people who would like to contribute to Pluto to do so and to reach out to us. Maybe Benjamin, you could say something about what do you think it would be like for someone to work on this feature? Like, what would that look like?
Yeah, I think what's obviously in a very, very early stage is that visualization of cell dependencies. This is on one hand because my JavaScript knowledge is very limited and I'm mostly working on the backend side. On the other hand, also, I think we should first develop a very good idea how to do that. How do we want to visualize the cell dependencies? There's an observable, it's somehow showing as lines beside the cells. That would be one possibility, or yeah, it's there are different possibilities, but there are definitely input would be very helpful. How could we do that? What would be nice and not too obtrusive and intuitive to do that in Pluto? And then, of course, it also has to be implemented on the front end side.
Right. And so to reiterate this cell dependency information since last week, it's available inside our front end. We just don't use it for anything yet. But if you know React, it's part of the state. So in your cell, you're free to fork Pluto and do something with this information. And please tell us what you did. Yeah.
Okay, let me just mention that the YouTube friends have posted that this is a game changer and it looks very handy. So it looks like people are seeing the value we're creating here. Also, an idea is to draw wires. Well, I would say wires are great, and this is what Excel does in the little thing function trace. The only thing is that you have to think how to do it correctly. I mean, the layout here is linear, so it needs some thinking, some designing. And we are very happy to do this designing with all of you people. You can join us at our Thursday calls, and we can discuss about ideas about how this can work. We can try things out and we can discuss them. There are so many ways this can work. Some of them are better than others. Let's discuss. It's very fun to have these nice problems.
Yeah, very happy to discuss, and ideas are definitely welcome.
Yeah. So if people want to get started, go to our GitHub, look around at our pull requests. There is a little guide on how to develop Pluto, especially front-end development, which is most of what we do. Is quite easy. You fork, and then you can just edit the source code and refresh. So just try it out. It's cool. It's fun. All right. Thank you again, Benjamin. This is an awesome new feature. We'd love to see more of it, and we'll go on to, I think, our final talk by Nathan Daly, who is also making a reactive notebook. Thank you, Benjamin.
Thank you. Bye.